Alrighty, what we are looking at today is polygons, and specifically, this is just kind of an introduction into polygons. Now, there's not going to be a whole lot of math involved, but I think that the terms and definitions and everything are super important. So, this does have some really critical information for your success with polygons moving forward. All right, so our objective today is, like I said, we're just going to be looking at the different properties. They're going to relate specifically to the sides and to the angles of polygons, and that's what we're going to be looking at here today. So, what is a polygon? You might be asking yourself that. Well, a polygon is, and this is the definition, but it's just kind of a lengthy one, but it's a closed plane figure formed by three or more line segments. So, it could be a triangle, it could be a square, it could be a pentagon, like what I have pictured right here. And so it's got to have three or more segments so that each segment intersects two other segments at their endpoints. Those endpoints we call vertices. So you can kind of see right here, that right here is a line segment. And so it's going to intersect this line segment right here, and it's going to intersect this line segment right here. So that's kind of where you have that this segment here is going to intersect those two line segments at their vertices there, or their endpoints. And so it's that no two segments with a common vertex are collinear. So basically, remember, collinear means together. That co means together, and then linear means on a line. So I can't have a segment like this and then have another segment that's like this, because that's all on the same line right there. So that's what a polygon is. Now, an irregular polygon is going to be very similar, but it's either going to be equiangular but not equilateral. So remember, equiangular is all angles are congruent, but not equilateral. If it's equilateral, that means that all sides are going to end up being congruent, but not equiangular, which means your angles are different, or it's going to be neither of them. And so this is kind of what I have right here. Like, you can see that each of these sides are going to end up being the same on there. So it would be an equilateral polygon, but the problem is that this angle is different than this angle right here. And so the angles are going to be different from each other. So that's where we get that it's an irregular polygon. All right, jumping down over here. Concave is a polygon in which any of the diagonals of that polygon. So a diagonal is when you go from a vertice, skip over one, and then you go to the next vertice that is over there. So this is what each of these diagonals would end up looking like on this. And so you can kind of see it's going to go like that. And then this one here is going to come down here. So it's not the sides that it's connected to, but it goes to every other vertice that is on that. And so it's going to be a diagonal that contains points on the exterior of the polygon. Well, that diagonal and that diagonal both have points on the exterior of a polygon. So that would be a concave polygon. Convex is just when the diagonals contain points that are on the interior of the polygon. So this is what we have right here. So the diagonal that I have is going to go right here. And if I drew both the diagonals of this polygon, you can see they're all contained inside that polygon. So that's convex. Now, equilateral, I've kind of already mentioned this, but equilateral is just going to be a polygon that all sides are congruent. So this is a square. So you can see all those sides there are going to be congruent to each other. That's an equilateral polygon. And then an equiangular polygon, or which all angles are congruent. Now, I could put a right angle here because I know that it's a square, but if you don't know that it's a square, don't assume that it's going to be that. But all of these angles here are going to end up being congruent to each other. So it is an equiangular polygon. All right, last ones here. One is the interior angles of a polygon, and those are just going to be the angles formed on the interior of that polygon. So I've got a star right here. So this right here is going to be an interior angle. And so these angles right here are all interior angles, and they are all congruent to each other. But you also have other ones, and the other ones are going to be right here on this piece there. And so that is also an angle. And so it just kind of goes from the side of, might help if I had my pen pointer still. So it goes from the side all around that vertice to the other side. And so those are all going to be angles as well. So that's interior angles. And then last is going to be the exterior angle. So it's just the angle formed on the exterior of the polygon. So very similar. These ones right here are exterior angles. But then just like the other ones, these here are also exterior angles. So some of those exterior angles get pretty big.